Hello, it's me, Nick, and welcome to the second video in the intro to Python for marketers. Now, if you've just landed here, you're definitely going to need to go 2 videos back to the intro to Python, which is outlining what we're doing here and what we're trying to achieve, and go back to the first video in the intro to Python for marketers so that you can know what we're about to cover in this workbook. Now, a little bit of housekeeping. If you've got any questions, stick them in the comments below. I'll do my best to answer them in timely fashion. Also, if you want to get a hold of this workbook or you want to learn how to install Python, there is a little series called Setup, I think it is, on the YouTube channel at DATABOI.com. Head over to that playlist. You'll see how to install Python in whatever machine you're using, whether it's Mac, Ubuntu or Windows. Anything else outside of that, I don't know. You're on your own. So if you need to get this notebook that we're working on, which is on the screen just now, in order to actually do this, so head over to github.com, the DATABOI, and you should be able to download it from there, no problems. So let's get started. We're going to dig into Pandas a bit more in this video because Pandas is so important for a marketer to learn. It's basically Excel. I said that in the last video because it basically is Excel, but it draws prettier pictures, runs quicker. Yeah, basically I think that's all you really need. It's not an all or nothing, as I've said before, but it will certainly help if you're dealing with like huge data sets. So let's get going. Open your notebook, run Jupyter, run Python. And first thing we're going to do is import Pandas because we need to use Pandas. It's a module for Python. It's not built into the core. So we ran that, nothing went wrong. On to the next one. We're loading the same data that we used the last time. And I named it the same, whether you like it or not. So that's KSMB data. So that's Kickstarter most backed data. And we're loading it in exactly as we did the last time. We printed all data loaded, bang, bang, bang. That means no problems. Next thing we want to do, remember we go through this process every time we look at data for the first time. We'll look at info to get a little look at the data to understand how much of it's in there, how much of it is blank, what's it comprised of. Is it floats? So is it decimal numbers? Is it objects, which could be strings and bits of text or numbers and characters? Or is it an integer? So you get a nice breakdown. A lot of this data is an object, which could be numbers pretending to be text. We would need to clean that up. Some integers, but yeah, mostly text data in this, which I suppose you would expect from essentially customer data. So once we've looked at that, we run the head again, or we run the head for the first time. Some people start with head. I don't like to. I tend to get too distracted by the visuals. So once we've run the head, which gives us the first 5, including the column names of the data set, you get to look at it. First time you're visualizing it, everything kind of matches the info panel. You'll notice if you're just watching this video for the first time, you'll notice that these are numbers, but they're not. They're objects because they contain square brackets and commas. So yeah, everything looks like it's there. Yep. And we've loaded the index column in here, which actually, you know what? We're going to take that out. We're going to play games. See how you can just change things. Okay, there's unnamed there. Okay. And unnamed looks the exact same as the index column here. So what we're going to do next, let's look at next. A lot of the data that you'll get your hands on, or at least a lot of the data that I get my hands on, have really annoying column names. Like Facebook data is the worst. They're super long. They've got big gaps in them. Now, Pandas will deal with that, but programs like Python, I think most programming languages don't like white spaces in naming convention. And I prefer to go with an underscore, and I think that's quite universal rather than a dash, because a dash could be seen as something else, particularly a minus sign. So, going to quickly rename columns, because you definitely will need to do this at some point. So first you want to get a list of the column names. So that's take the data set, so KSMB data, and then put .columns afterwards. And what it will do is it will give you a list of the column names. In some instances, depending on how many columns you've got, it might not show all of them. It might kind of tourniquet them. But there's ways to get around that, but highly unlikely at the moment you'll be dealing with that much data. So we've got the index here and of the column names, and we want to change unnamed because there's a big space in it. The rest of them don't have spaces. We want to take that unnamed out and maybe give it a more useful name. And in this case, I think it's good to probably just call it ID. So in order to rename, it's the same function no matter how many column names you want to rename. So you just use the data variable name. So it's KSMB data.rename. I'm going to really regret naming it that because it's so difficult to get off your tongue. .rename. And then you're going to say, I want to rename the columns. So rename columns equals. And what this is a Python dictionary. You will learn more about these in the future. And essentially, it does what a dictionary is. You say unnamed ID. They're the same thing, essentially. And put comma, because we're going to give it another function to do within rename. And we're going to say in place equals true. What this does is it essentially overwrites the data frame with the new information. So let's run that. No problems. It ran fine. There was no syntax errors. That's usually your problem when you're coding syntax errors. And we're going to look at the head, and there we go. You can see up here we've got unnamed. But down here we have ID. If I didn't put in place, it would just have opened it here and showed us it in this window. Kind of like it just showed us the whole data set with that in it. But we wanted to replace it. We didn't want to just see what it looked like. It's a bit odd that. Let's see what ID looks like in the data frame. Does it suit? No. So we now know how to rename column names. That's going to be really useful, especially in the next video. We're going to rename some of the column names. Next thing is getting rid of annoying characters. Now, I don't want dots in my column names. It's a preference of mine. It could mess with some of the Python functionality, but it's more like I'd rather not have them. I'd rather just have no space, nothing, just compress them together. Or equally, I could use underscores. So what you'll see here is we're going to use the dot columns again. So KSMB data dot columns equals, and we're calling it again, and we're saying essentially look up all of the columns, the strings in the columns, and then replace them. Replace this dot, so these here, like num.backers. Can I let you get the idea, right? Replace anywhere that you see a dot in there with nothing. We could put a space in. Don't want spaces. You could put an underscore in. I don't want to put an underscore in, so we're not going to use that. So there we go. And if we look at .info, it will give us a list of the column names, and as you can see, all of the column names have no dots in them, unlike all the way up here where we'll have seen dots. So that's pretty straightforward. You're just basically tidying up your data in a way that you like. So let's skip down. Let's explore a specific column or series, as it's called in Pandas, and it would be good if you start picking up the terminology, because you're going to need it when you get stuck and you have to Google things. So in Pandas, it's a series of data in a column. So I just made this up. This is not necessarily going to yield us any useful information, but let's look at the location data. Let's see what sort of functions we can use on the location data, which is a string, not numbers. So we're going to put the location data in a new variable, and it's going to be called loc data or loc data. So we've run that, no problems. How many unique locations do we have in this campaign? Let's do this. So that's loc.nUnique parenthesis, I can never say it. So there's 806 unique locations in this dataset. Let's produce a list. Okay, let's have a little list of these unique ones. So it's nUnique gives you the number, and unique just gives you a straight list of it all. It's a little bit messy. I can't really read that properly. So how would we maybe tidy that up? We would turn it into an actual list, because right now, if you look here, it's an array. So it's just pumping out the raw data. So let's get it into something a bit more uniform, a bit easier to read. So if we put list, then highlight it, put it inside brackets, hit return, the array disappears, and it is now giving you a nice list, and you can kind of scroll through and you can see that it's all American cities, I think. Oh no, there's Korea and Germany. Oh, it's not, it's all over the world. See, I learned something. So that's how you get a list of location data, if that's what you're looking for, or a list of unique values from a set of text. You could be using keywords. You could be looking at ads to see how many times you used text in ads. Anything at all. Okay, so what are the top locations? Maybe we're wanting to target cities for some reason. So we're going to put this in a new variable on its own, because we might want to manipulate it later. So %loc or loc, whatever way you like pronouncing things, equals loc data dot value underscore counts. So we're going to count the values. Then we're going to print the head. See if you noticed. Printing the head didn't work because Python runs things in sequence. So we're going to add this in here. We're going to put the head in there. But let's have a quick look at this data set. Oh, damn it. No, actually. There we go. That was the right thing. Best to put them in individual cells, so you can see them running at different times. So we ran that, and now we're going to look at %loc head, just so it's basically, if we remove this, we get a big list. A big list that we don't really want to read and see these dots. That means it's not showing you every row because there's too many. So we're just going to look at the head because we're only interested in the top stuff. So let's see top 10. So you can see after about 100 it starts really dropping off. So San Francisco, I don't think that's surprising to anybody, is I'm just checking something here, sorry, is the highest actions, I think. Let me just check something I want to check. So the location data, I can't remember off the top of my head, but it will be on Kaggle. I don't know if the location is backers, so potentially it's backers. So the most campaigns, or no, it'll be campaigns created by, and most of the campaigns are created in San Francisco, then Los Angeles, then New York. So like really West Coast, dominated by the kind of West Coast and East Coast of America, and then London, which is nice to see. Let's see this value as a percentage. So again, we're just going to overwrite the variable we've got. We can do that. We can overwrite it later on. So %lock equals %lock value counts. And then inside value counts, we can set it to normalize the data. So you're not seeing true numbers. And we're going to hit this. There you go. As a percentage. Don't know if it's any more useful, but if you do need percentage, essentially that's how you will get it. Or the normalization even, not just the percentage. So, we've played around with data. We don't really know what we're looking for. We're just playing around with the data to understand how we use Python on random data sets. Let's have a look at filtering in Pandas, and this is the last section. I do this a lot. If you're doing keyword research, you end up doing a lot of filtering. We're going to do a particular type of filtering. So we'll just work through it and we'll see how it goes. I don't want to spoil the surprise. So let's get the column names up, because we'll assume we didn't do the good work before and we just skipped ahead. So, columns. Nothing new there. It's not got the dot in it. It's got ID as unnamed, has changed to ID, so that's great. Carrying over. So how many? Let's filter numbers. We are going to look for the amount pledged greater than $100. We're assuming, and the goal also greater than 100. So we call our variable, then we put a little square bracket in here, as you can see each end. Then we look up the specific column and what we're looking for in the column. So there's a specific column, and it's everything that's equal to or above 100. And little and, see, it's just like English. We look up this specific column with, again, greater than 100. I don't know what we're going to find. So we've run it, and it has given us this data set. Ooh, it's very big. So how many? 3,000, almost 4,000 rows of data. And that is everything over 100 amount pledged and over 100 goal. This is most of the campaigns, not all of them, but most of them. And we can play around with that. We can do, let's do 1,000, just to show you the working. And what you'll get when you get to the bottom is roughly about the same. Interesting. Let's do it more. Let's see if I've got an issue with my code. Yep, it's going down. So no issues with the code. It works fine. Let me just change these. I don't want this book to be too different from the one that I'm uploading. Oh, there we go. Let's run 100. Okay, let's store this data in a variable because we might want to use it again later. So there we go. Simple as that. We can look at the head of the data. Stored, just waiting there to be picked up later on. Maybe we want to bind it with another bit of information later. Just means that we can store all our filtering and we don't need to keep redoing our filtering, which is what I find a total pain in the ass with Excel. Next thing, let's look up a combination of, little text mistake there, combination of words in a series. So we're using the same information, the same technique technically, to look up words, but we just have to use a different function. And you've seen this one already, kind of. You've seen its cousin. str.contains. So same structure as before. Square brackets at each end. Okay. What column? This is a column we're looking up. and that's contained inside those two brackets, two regular brackets. There you go. And then we've got, so look up the string in this column that contains the word film, or, so this means or, look up in the, so the first one is look up the category that contains the word film, or in the blurb that contains love. And then print the head. So you can bolt head on in the end there, see? Don't always need to create a new variable to do it. So as you can see, we've got some with film, some without, and that's because the blurb, which we can't really see here, which isn't great in that sense, the blurb will likely to contain love somewhere in there. So we'll get a mix-up of different content. Again, don't know why we would do this in this particular data set, just showing you the functions that you could use with some of the stuff you're working on. It's universal. Okay, now we're going to do something very similar in this last set of data. We're going to look up category again, video games, and this time the blurb contains school. Really weird one, I think. Ooh, managed. It works. So all video games. Again, so we'll get old school. No school there, but we've got to assume that the machine knows. There we go, old school. So that's essentially this workbook. So it's what we've did is we've looked at the data again. We have renamed columns, so we've started to act upon the data. And we've started to filter, so break down the data into little chunks, and then we have started to filter the data because that's very important. You'll notice that I've only tackled the contain stuff because it's a bit harder to do does not contain. You require a bit of regex currently. Hopefully somebody in the Pandas team will deal with this and create a nice little module or a little function that will deal with this. And we're not ready for regex yet. In fact, I'll probably do an entire video series on regex for marketers because it is really useful. You can use it in Google Analytics, but it's not for right now. We don't need that complexity in our life at the moment. So that's this workbook. Again, if you need any help, I've got something I've not made clear, stick it in the comments below and I will get back to you as quickly as I can, hopefully with the right answer, or not sure, you might need to Google. And the next two videos will be up in the next couple of weeks. And just, yeah, feedback, need a lot of feedback. Hit subscribe, hit like, up likes, not down likes. I mean, if you're going to complain, just tell me and then I'll fix it. Down likes are really passive aggressive. So yeah. Thanks for watching the video, and hopefully you're learning something. Ciao!